This video is on proving the law of sines. So proving law of sines. So we are going to start by defining how to find the area first, area of this triangle, using a little bit of right triangle trigonometry. So we know that the formula for area of a triangle is equal to 1/2 base times height. Okay. Well, in this case, we have a base of b, so we're off to a good start here, 1/2 b. But we're going to express our height using a sine ratio instead of using h. So going back to our right triangle trig, we know that sine of an angle is equal to opposite over hypotenuse. So sine of c is equal to h over a. So I'm going to go ahead and solve this for the height, or our altitude. We'll multiply by a. So I'm going to plug this into our area formula. Instead of plugging in h, I know that h is equal to a times the sine of c. So that's going to give us 1/2 ab sine of c. All right, well, let's do this again, but let's use, this is our angle, our angle of interest. So again, our base is still b. So sine of a is equal to opposite over hypotenuse, h over c. So I'm going to, again, I'm solving for h, so I'm going to multiply both sides by c. So using that same area formula, 1/2 base times height. All right, so you can see these two areas should be equal to one another. We're still dealing with the same triangle. I'm just expressing it using different sides here. So I'm going to go ahead and set up an equation. So we have 1/2 BC sine of A, and we know that should be equal to, or is equal to, 1/2 AB sine of C. And we could prove along the same lines that 1/2 AC sine of B would also give us the area of this triangle. So let's just think about this for 1 second before we move forward. Notice that B and C are the sides that make up angle A. And notice that B and A are the sides that make up or come together to give us angle C. And notice that A and C come together to give us B. This is a really great formula for finding the area of a triangle that is not necessarily a right triangle. So that all you really need to know to find the area, all you really need to know are two sides and the angle between those two sides. So this works for any triangle. So the area of this triangle would be 1/2 times 7 times 8 times the sine of 30. And then you could either plug that into your calculator or use your knowledge of 30, 60, 90 triangles. But the point of this was to get us to the law of sines. So I'm gonna go ahead and go on to another page here. So what we left off with is 1/2 AB sine of C is equal to 1/2 AC sine of B is equal to 1/2 CB sine of A. So to get our law of sines, I'm going to first take this and multiply everything by 2. So when I multiply everything by 2, my 2's all reduce out, or my 1/2's all reduce out to 1. So I'm left with AB sine of C is equal to AC sine of B is equal to CB sine of A. Well, my next step, and again, we're allowed to do these things because it's an equation. So as long as whatever you do to one side you do to the other, it's fair. So I'm going to divide everything by ABC. And as long as I'm doing this to all parts, it's a legal move. So when I divide this by ABC, A divided by A is 1, B divided by B is 1, and we have sine of C over C is equal to A divided by A is 1, C divided by C is 1, and we are just left with sine of B over B. See a pattern emerging here? Divide everything by C, Divide by b goes to 1. We get sine of a over a. And there you have it. That is your law of sines. But let's actually work with it. So seeing the law is great, but being able to work with it is even better. So let's go ahead, add a page here. Let's go ahead, take this triangle here, and let's say we have, this is a side of 8, this is an angle of 40 and a side of 10, and we want to solve for, let's say, side A and angle A. So to use the law of sines, to be able to use it, you need to have at least one known angle side, one angle and side opposite that angle pair. So we have angle 40, and opposite angle 40 is 8. So we do have one known angle side pair. We also need one other bit of information. So one other bit of info. It doesn't matter what. I have side 10, that's great. I could have another angle as long as I just have one other piece of information so I can set up that proportion. So remember, law of sines is sine of A over A. All this means is sine of the angle over the side opposite that angle. So the letter really doesn't matter. You just have to remember side of angle, or sine of angle over side opposite that angle. So here I have sine of 40 over 8 is equal to sine of, since I am looking for angle A, I need to set up my proportion using the side opposite angle A, so 10. So 10 times the sine of 40 is equal to 8 times the sine of A. So I just cross multiplied here. So I'm going to divide both sides by 8. Here we have the sine of A is equal to this lovely mess. And at that point, you would grab your calculator and evaluate what 10 times the sine of 40 is divided by A. But in this case, we are solving for an angle, not a side. So anytime you are solving for an angle on your calculators, that's when you have to use your inverse sine function, because that's saying, give me the angle whose sine has a ratio of this value. So that's when we use that. So first I'm going to evaluate 10 times the sine of 40. Ooh, I don't think I'm in, hold on, let me check my mode. So if you're using a TI-84, one of the first things you should do is check what mode you're in. Just clear all this. So I am in, didn't mean for that to, I am in radian mode, but I want to solve this problem using degrees, so I'm going to go ahead and switch to degree mode. So TI-84, I went to second mode, and then second quit will get me back to my home screen. So now I'm going to type that in, 10 times the sine of 40, close parentheses, go ahead and get that answer, and then divide it by 8. Now I want the inverse sine of 0.803. So second sine, 0.803. And that's going to give me 53.4. So this was 0.803, and that gives me 53.4 as angle A. Now, this is just one possible triangle, and I'll save the ambiguous case for another video, but there is a possibility when you use the law of sines that you could potentially have two triangles that satisfy these measurements, but I will save that for a future case.